What?
Official or unofficial streaming?
This is Gus's stream. It's going through Periscope, the Twitter thing that does the streaming video.
So we're live at Periscope.
Yeah, we're live. I actually have a slide in there that says, Jason, remember to press the red button. At the end, it tells me to remember to swipe and press the red button.
So it'll be a 17-hour video. 18-minute talk. 15 hours of black.
8-minute talk.
15 hours.
Oh.
Tomorrow morning when you come in and realize you forgot to press the button.
It's great.
You probably houses. Start doing some paranormal activity.
You're like, what was happening at 1 a.m.?
I don't know if I want to know it's just like there's people in this already, so you never know.
Who are they? Are most people in here alone? All right, let's get this thing started. Come on in. There's chairs, you can sit down. Don't be afraid. Or be afraid of the chairs, doesn't matter to me. I'm standing the entire time. All right, so this is the something other BucksCoutyTech meetup. It's been more than a year now. We're still going strong. I'd like to thank everybody for coming out tonight. Just a couple reminders. Parking out there is paid parking. Please help yourself to the pizza and the drinks in the back there. And after the presentation, a lot of us will usually go over to Triumph. Drink, have a good time. It's right across the street. A couple thank yous to the people that actually do all the hard work. Nita for ordering the pizza. She always does a great job at getting a wide variety of pizzas. Me, I would just choose plain and that'd be it. You'd be suffering. Dave for actually setting everything up. I don't even set everything up. Tom actually prints out the name tags, prints out the signs, make sure everything's squared away. I don't even print out the signs. Mimi for hosting the place. I couldn't be bothered to set up hosting for this. RedLine13, the people behind that, for actually putting out a product that I want to talk about. And you for attending. So this is the part where we go around, we make everybody uncomfortable, and we ask for introductions. So I'm going to point at you, and then we're going to go around the room, and you're going to simply say something along the lines of, "Hi, my name is Jason, and I'm a programmer here at Meet Me."
Hi, I'm Matt, and I'm a programmer here at Meet Me.
Hi, I'm Jordan. I'm a team lead at Discord. Chuck, I'm a senior.
Rich Friedman, I'm founder of RedLine13.
Derek, operations at Apache.
Jeremy Simpson, VP of Network Operations here at Meet.
Cyrus, backend developer here at Meet Me.
Hi, Lennox, database developer at a small firm in Watching Fussing.
I'm Chris, I do what Jason does.
Mike, I'm a front-end dev out of DoS.
I'm Ken, I'm an enterprise architect, and I'm looking for new opportunities.
I'm George, JavaScript.
Township. I'm a Linux designer and
All right. Just a heads up for the next 3 months. I just want to give you guys what talks we're going to be having here. Next month, we're going to be talking about QA automation. It's going to go through automation of quality assurance, the different ways to go about doing that. It's going to be an interesting talk. I know that our QA lead here is going to be also, in addition to the speaker that we have coming out here, he's also going to, we have our QA leads who's also going to be talking about what they've been doing to bring QA automation into mimicking. Then in October, we're going to be having a talk designing for Android. We're actually going to be having one of our designers here at mimicking. He actually uses an Android phone. If you know designers, you know having a designer who uses Android is like a unicorn. They don't exist, and yet he does.
Do we get to heckle David?
Yes, you do. Designing for Android. I think it'd be a really good talk. It's a talk that I've been looking forward to for quite some time now. And in November, we're going to be talking about systems monitoring, more of the back-end stuff. I also want to open the door, just make it clear that we're always willing to accept people that want to present themselves. We don't do a meetup in December, but we do have January available. So if anybody wants to propose a talk, you have some time. And just if you're not sure about how you prepare a talk, I want to present to you the 5 Ps of perfect presentations. This is the thing that I use to make sure that my presentations are always as high quality as you're going to see tonight. The first step you do is you procrastinate, and then the second step is you procrastinate, and the third step is you procrastinate, and the fourth step is no, panic. Thank you, David came up with the panic idea. And then the fifth one is you present. That's the fifth one. And all speakers know that this is pretty much true. There's probably a 4.5 step where you prepare the night before, but yeah. So, we're here to talk about RedLine13. Don't forget the 13, because if you search for Redline on the internet, you're going to come up with a whole bunch of different things. The safe version is Redline the movie. Apparently should not be missed. There's Redline Extreme. This also helps you with performance. And just like Redline13, it has 0 sugar, 0 carbs, and it's non-carbonated. So I thought that was pretty cool. If you search for Redline, you will get red lines. You will also get maps of metro stations with the red line. Did you know there's a bike called the Red Line? Yeah? And finally, who could forget Redline synthetic oil? So don't forget 13. Also, we're going to be live streaming this through Periscope we are right now. This is the slide in here that I put in to make sure I didn't forget to press the red button. I've already pressed the red button. There's a slide at the end that tells me to stop, to swipe and press the red button to stop the streaming too. So, because I would forget. But we're here to talk about load testing with RedLine13. So I want to talk briefly about what is load testing. I don't want to bore you too much with the background of load testing. Is anyone here completely unfamiliar with what load testing or stress testing is all about? All right, good. We don't need to spend too much time with that. But essentially, it's putting demand on a software system and measuring its response. That's essentially what load testing is. And what we want to do is we want to determine the system's behavior under load. And this is really critical because it's not just about measuring response. We want to see what happens when we put a lot of users, queries, events, action on the server, on the system, whatever we decide to load test. And the things that we want to identify is the maximum operating capacity, and we also want to identify the bottlenecks of the system that we're putting under stress. There's also a term stress testing. Technically, load testing and stress testing mean 2 different things. I'm going to use the phrase load testing interchangeably a lot. Essentially, stress testing is focusing on the throughput, whereas load testing is focusing on the response times, and both can be performed at the same time or on the one on the way to the other one. Technically, load testing is a subset of stress testing, but that's really not important. It's called load testing. So load testing is putting a demand on the system, measuring the response, determining the behavior under load, determining the maximum operating capacity, and figuring out the bottlenecks. And this is what we're going to talk about and using Redline for, and what we're going to show in the presentation tonight. Just a brief discussion on the other load testing tools. You have the old standby Apache benchmark. I'm sure we've all whipped out AB and put in a URL, and we've used that to benchmark things. Siege is also similar in that regard. There's Apache JMeter. If you like, a downloadable application has a gazillion options, and you have to learn how to use it, and it feels like you are never going to get to actually load testing something. There's BlazeMeter, which is I would guess it's a competitor to Redline, if you want to say it. You know, if you want to consider their, I mean, after tonight, they're not really a competitor because it's really easy. Why RedLine13? There's a couple reasons. One, it's simple. It's using the stuff that you already know to do the stuff that you want to do, which is load test. This is what I really like about it. You can code your load test, and this is what we're going to be talking about tonight, is custom load tests. It's very inexpensive. Rich, you can charge a little more. I mean, and it would still be almost free load. This is their tagline, almost free load testing. You know, it's incredibly insane, but it's very inexpensive, and you only pay for what you use. It is scriptable, as I said, so you have complete control of your test. There is simple tests where you can simply do stuff like A/B testing. It'll make things simple for you. I've never used those features. I always go straight to the scripting realm, mostly because I'm testing against APIs. And this is one of the really nice things that I like, is that it's scriptable. And it's backed by AWS, so it has the capacity for infinite scalability. Infinite scalability, above that line. The final reason why I started using RedLine13 is because I know Rich, and he recommended it. So he was like, hey, you should check this out. But no, I'm glad he did. Anyways, it has a whole bunch of features. You can go to the site, you can check it out yourself, you can read about it. You're not here for me to regurgitate what's on the site. So we're going to talk about the basics. We're going to show you a quick overview of what the basics of RedLine13 does, and we're going to do that with pictures. So RedLine13, this is the front page here. You're going to go here, you're going to sign up, you're going to do the whole thing. This is going to be your main load testing screen on Redline, and it gives you just briefly the load test, the success rate, blah, 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 a bunch of boring stuff. And then it gives you can click the button there to start a new test. This is the simple test screen. You can see some basic stuff here. You can put the URL in, the number of users, the iterations per user to hit that URL, the minimum and maximum delay, some basic stuff. Click a button, start test, and it's done. We're not going to talk about the simple test because, again, that's fairly boring. You're all intelligent people. You're programmers. You want to get to the really cool stuff, the custom testing. This is the custom test stuff right here. This page allows you to upload a custom test, and I think I have the video right here. These are my live demos. They were live when I did them. So this is me uploading. I have a load test called Reloaded. So put our AWS instance information in there. The subnet ID and security groups are blacked out because I don't know. We're doing Node.js. All our code demos are going to be bad Node.js. We're going to hit put in a description. Might take a long time. This will pop up. If you start using Redline a lot, you'll get used to this window right here. You're sitting there waiting for that. I see that window a lot every time I start one up. It's okay though, because when it goes away, the load test is starting and it's like, yay! It's a lot of fun. Who here's ever done a load test before? Performed load tests? Who here has had fun doing load tests. Ah, man, it's because you're not, this is awesome. All right, I think this is actually the end of this one, because if you go to this one, then I said I skipped the waiting period. It does go out to AWS. It does use was a Spot or whatever. It figures out the cheapest way to run your load test, and then it assigns the servers, sets everything up. It does a whole bunch of stuff behind the screen, behind the scenes. You really don't care about that. Come on. There we go. So then this will pop up, and then this will go away. We're actually going to see what a sample load test is. So you'll see the details, you'll see what servers you're running on, and you can set up what servers that you want. Redline will, given the number of users you want, will place the users on the different servers as it sees fit, but you can always assign them how you want. And this is a basic overview, requests per second and average response time right here. And this is a very simple basic load test, low number of users that I just wanted to do to illustrate how all this worked out. These right here, the load CPU agent right here, this tells you what the load like is on the server, which is probably good to know if you have a load testing custom script that's using up 100% of the CPU. That might be impacting the performance of your load test. We'll get to what all that is down there. That's me hacking Redline. There's actually a section called hacking Redline in here. All right, so this is basically what a load test looks like when it's running. So before we jump into actually walking through the code of a load test and some of the things you should consider when writing a load test, we're going to talk about preparing for the load test, because this is actually somewhat important. You should never just jump into writing a load test. There's a couple things that you need. First of all, you actually need a production level system to test against. You need something to test against. This sounds like it's sort of obvious. Like, well, of course, if you're going to load test something, you need to load test something. Why would you put that in there? But you need a production level system. You don't want to be load testing a system for performance or requests per second or response times and say, well, let's just throw it up on a T2 micro or something on AWS. Be like, that's enough, right? If you're going to be, you want to throw this up on whatever production environment, production-like environment you're going to be testing against. It's important to do this because that's going to give you your the actual results that you need. You should have monitoring. You should have monitoring. You want to be able to see what's happening. And so all sorts of monitoring should be included before you start your load test. This should be already prepared. So you should be able to monitor the CPU, the memory, the I/O. These seem like simple things, but you don't want to come in for a day of load testing and not have all this stuff already prepared. The application dashboards. So if you're load testing an application, an API, things that are actually going to happen. You're going to load test a chat system. You want to have some sort of dashboard that you can refer against. What does the application's dashboard look like so you can look at the results of your load test? These are all things that are incredibly useful. Logging. You want to make sure logging is already prepared. You want to make sure that you can access the logs. If something's going wrong during the load test, something's not performing well, you want to be able to find out where the logs are. Even as long as you have access to those logs. Again, you don't want to be waiting for the day of the load test to actually try to figure out, to try to get all this stuff. You want to also see if you can get, oh my gosh, do this manually. You want to also see if you're going to do any automated systems, if you want to try to get any of the automated systems to deploy, you want to make sure that's all prepared as well. So if in the process of running your load test, you want to try out a different instance on AWS, what you can do is you can simply spin up the new system. And if you have an automated deployment mechanism, either through Chef or whatever system you're going to, an AMI or whatever system you're going to deploy, you should have that ready to go as well. You don't have to necessarily do all of this. You can get dedicated people to help you. The one thing I like about whenever I'm running load tests is I like to go in and I'm sort of the red team. If you ever saw like, was it newsroom. They had like the red team, the people that had no idea, and they came in with a fresh look, the fresh outlook on what's going in. I like not knowing. I like not being involved in the construction of the application that I'm going to load test. So I get all the people that were involved to do a lot of this work. I say, I need this, and I need this, and I need this. They provide it for me, or they don't, and then we get upset. But I make them do all that work. Because they should have this, especially if it's going to be going to production.
What tools do you use for monitoring?
So we're using, so we use New Relic, we use Graphite. There's New Relic is a big use. It could be as simple as, though I don't recommend it, it could be as simple as logging in and running top on the systems and just seeing what the performance is on the systems themselves. The individual applications themselves, or whatever services that you're using. I recently did a load test with Elasticsearch, and that has its own Marvel plugin that you can use, that you can review, and so the applications that you might be load testing might also have their own built-in monitoring systems, their graphing systems, their own application dashboards. You just want to have as much of that prepared as possible ahead of time. Finally, you also need a time to test. I highly recommend you set up a dedicated time. This, again, sounds simple. It sounds like it's pretty obvious. Yeah, okay, I'm going to load test on Monday, but you want to make sure that everyone that's going to be involved in this load test, which also means the application engineers who actually program the thing, the network operations people that are actually deploying this, or the DevOps people that are actually deploying this, you want to make sure that you have somebody there from each one of those teams ready to work with you to make sure that this system can pass the load test. And set up a time, set up a location, and say, okay, we're all going to sit in here and we're going to make sure that this gets through this. And they can look at things while the load test is going on and see if their application is performing the way they expected. Just because everything on your end, the response time and the request per second, seems to be going really well, doesn't necessarily mean things on the back end are looking just as good. You also want to set some goals. You want to learn. A load test is all about learning. So you want to set your goals. Recent load tests that I performed, we had a simple goal of 50 millisecond response times at 500 requests per second. That was a simple goal. How we came to that goal, I think it was based on the assumption of existing system, and this is sort of what we'd like to hit. But this is the number that I was given, and so this is what we were tasked to. These are goals we wanted to have to achieve through the load testing. You want to also have test monitoring. You want to test the monitoring that's going to be on the system. So if you have any monitoring set up, for example, Sensu, if you're using New Relic and maybe their alert system, this is also a good time that you can make sure that their alerts are in place as well. Granted, during load test, once you verify that the alerts work, you're probably going to want to turn them off because they'll continue to go off. But at least you now know that they work. You want to test scaling. You want to learn how your application is going to scale. Load test, you're going to hit that limit. You're going to hit 500 requests per second and 50 milliseconds. Okay, great, you hit that. Now, what happens if you throw 1,000 requests per second, and how do you get it to stay 50 millisecond response time? So what do you need to do to scale this out? This is where you learn how to scale your system. You also learn what happens to the app under load. And this is important because just because you're sitting on your laptop or your mobile device, you're using an API, you're testing something, it's working really well, you're getting really fast response times, doesn't mean it's going to stay that way when it's getting 500 requests per second. Things will change. And the only way you're going to find that out is when you're actually putting the system under load. And you also want to find out, you want to learn what slows down first. It's usually going to be something you may not have expected. Something will be a bottleneck that it may be what you expected, but I found that it's generally the thing that you didn't expect which will hit you first. So you'll find that out. You'll figure out where the bottleneck is, and you'll have a firm understanding of this is the bottleneck. And then you'll be able to plan how to scale that out, how to solve that problem before you actually go to production. As a load tester, as the person actually performing the load test, these are some of the things that I usually take responsibility for. Basically, that the people involved with the test are aware that I'm actually performing the test, which is important, and also that they're available as a resource to me while I'm performing this test. If something's not working, if I'm expecting to hit a certain URL to test an API, and that URL is not working, I shouldn't have to put in a ticket and wait 2 days to get a response back. I should be able to, go up to somebody or have someone sitting right next to me or on chat working with me and say, hey, this isn't working, and have it fixed as quickly as possible. As a load tester, you're also responsible for putting the system under test under load. This should come as no surprise, but you're actually the one performing the load test. You need to make sure you put that system under load. That means you need to stress that system, which means you need to go as far as completely destroying the system under load. And I don't mean physically destroying the system under load, another type of stress test for that. But the greatest joy I have is throwing up a whole 500 requests per second and then seeing the thing fall to a halt and watch the system crumble and turn to the guys that actually built the system and go, it needs to be faster. I need more cowbell. We need more. It's your responsibility to put this load on there. And so your test needs to be as accurate as possible. It needs to do the things that you expect a high-performance system to be able to take. And you need to find that limit, and you need to beat that limit, you need to break that limit. And finally, you need to provide a clear and concise report after the fact. So you need to keep track of everything that you're doing. When I show you the code, because it's code, it's going to be version controlled. So everything you can replicate. You need to keep track of how you were testing the system, what requests per second were you aiming for, all the events that were occurring. And then when you're finally done, you need to provide a clear, concise report to the people that asked you to perform the load test. And we'll talk about that in a bit. Oh, there's one more thing. You need to have fun. You need to take charge. It's fun. Guys, load testing. The nice thing about load testing is it's someone else asking you, paying you. Here, take the system that I lovingly built, this handcrafted, organic, all natural code, bash it to death. How could you not love that? There's another thing you need to consider, you need to prepare, is ramp-up time. So if you have the timing, if you have the response time, 50 milliseconds, and you have the request per second, in this case 500 requests per second, you should also prepare ahead of time, the expectations on what burst traffic will be. So you can simply say, well, what do we want to scale to? What's our goal to scale to? What should we be able to handle to? And so you should also account for ramp-up time when you're preparing for the load tests. And in our case, in the most recent load test, I decided we were just going to ramp up to 9. We were going to add 900 requests per second to the already 500 requests per second, and do a ramp up over 20 minutes, 40 minutes at peak, and then ramp down. And that would test additional things. You want to make sure that that's something that you have consistent, you have planned with your load tests. So now we're going to talk about reporting. Does anyone have any questions so far? Feel free to ask questions. To neighbors too, I don't care, you can talk amongst yourself. Reporting. All right, so there's three levels of reporting that I like to give when I do load tests. There's the simple version, the shortest version. This is the result after our last load test. This was my shortest version, a 99th percentile at 59 milliseconds. That was the result of the load test. If you needed to know anything, if you wanted to have the quickest, easiest view of what the load test accomplished, it was 99th percentile. 99% of the people had 59 millisecond response times or less. Simple, to the point, gets right out there. You don't need to worry about anything else. There's a short version. It talks about exactly what we did. I highlight the fact that when we were scaling, the 99% of the people, it was just over a second. But that was when we were scaling up. And then after we had scaled up, we had auto-scaled, we were back down to down to the 59 millisecond response times. This is stuff that we can tweak by tweaking the algorithms in the auto-scaling features of AWS. But this is the short version. And then the final version of a write-up is you want a detailed version. So you have the shortest version, simple and to the point, a short version that'll just give you the basics of what the test was and then the results of those tests. And then a more detailed version. And this is where you want to walk through exactly what you did, the results, sort of story-driven, explain what you did, why you did certain things. Keep it short, or don't write books about this, but keep it concise. But you want to have detail in there. You want to make sure that in this report that you account for any changes that might happen. For example, one of the things that we had was while we were auto-scaling and when we weren't auto-scaling, so when we were auto-scaling, we were adding more servers to the system, and so there was definitely going to be fluctuations in the timing, and then I wanted to make sure I called that out. This is a quick example of a more detailed report. You don't need to read it, but gives a little bit of the background, some important, calls out an important chart, and a lot of it highlights a lot of the critical details. One thing you want to do when you have any sort of detailed report here is you want to make sure that the things that made up this report, the data, the code, everything that made up this report is available to anybody that wants to look at it. Again, because you're going to be writing code for the custom tests, the load tests, you want to make sure all that code is in some sort of source control, whether that is Git or Subversion or Mercurial or I don't know what else is out there, anything. Source safe.
Two questions. One, what did you learn? The interesting part about the auto scaling versus not exactly the load testing piece, but did you learn anything from doing the auto scaling? Any ways to compensate for that?
Yeah. So first of all, the one thing we learned immediately was when we were auto scaling down. The way we were auto scaling down, we were testing. We were load testing our an Elasticsearch cluster. And one of the first things we learned when we were auto-scaling down was that when it auto-scaled down, it just simply shut the machine off. And this would cause problems with Elasticsearch because suddenly it's like the way it was sharding things out, it was like there's data that's missing. And so we're like, oh, it's a good thing we learned about this now. It's a simple solution. You just literally make sure you have something in shutdown, a script that calls out to the service and says, hey, stop. And Elasticsearch does the rest. But it's important. We only discovered that because we had actually scaled up beyond what we needed. And this is why you want to make sure that you not just plan for the load that you're going to have, but also go beyond the load that your machines can support. As far as what we learned to alleviate those problems with these timings might have, so a couple things. One is we're monitoring on the CPU. So we started out at 80% CPU usage. Once we hit 80% CPU usage, we'd start spinning things up. We brought that down to 50% CPU. We did 80, 70, 60, 50, and 50 we found to be a good compromise. And we could also do additional testing to see if, so right now when the machine gets spun up, it then runs Chef on it, and this is going to run Ruby code. It's going to start pulling things in, so we can go the route of actually setting up our own AMI, and it'll just be installed right away. So it spends less time building it. We don't know how much of a performance gain we'll get with that. We could easily test it, but the settings that we put in were able to meet what we did.
And the second question was, how many iterations of load tests does it take to figure this out?
I don't know. Okay, so one of the things that what I like about Redline is because it's so cheap, literally like starting stuff up all the time. You're like, oh, I'm gonna start this. And then maybe after 5 minutes you realize, okay, this is not getting, it's not the results. Tweak this knob, but we can start it again. But yeah, we were just iterating and iterating. We throw a load test in. We spent all week just doing load tests, and we just try different things out. At one point we had multiple load tests going. one on an R3X large and one on a C3 4X large cluster, and comparing the two. We actually got, it's not, you can't really see it here, but we did a price comparison, and what we found was that once you hit 12 R3 large instances in Amazon, you hit the same price point as 5 C3 4X larges. So they'd be $4.20 an hour. But you needed to get close to what the C4s could provide. You needed 17 R3s. So as soon as you hit 12 R3s, it made more sense to go to the C4s. And because the load that we were expecting, 500 requests, the load that we were testing for, 500 requests per second and 50 milliseconds, was easily met on the C4s and needed 17 R3s to meet that. It was just like, oh, we can go to the C4s. We can go right there off the bat. And they could actually scale out a lot more than just 500 requests per second. So that was so it definitely saved us a lot of money there too. One thing I'm gonna stress on this is you want to make sure that everything is repeatable. So when you're performing your load test and you're writing your reports, you want to make sure you always reference load tests. I forgot to do it this time, but it's always a good idea to also tag your load test if you're making changes. Because it's in code, you can tweak things. You can say, let's try out a different query. Let's try calling it in this order. We'll get to all that later. But make sure you tag your load tests in Git or whatever in some way. Tag it, version it in some way. Have it always be repeatable. I should note Redline also stores the custom tests. You can actually download the custom tests as well. So you could always do that. But if you want to be able to reference, say, oh, what test did you perform here? Let's do that one now, not C4s, but let's not use C3s, but let's use one level up. You can quickly and easily get that information without having to go through and search for it in Redline. So let's actually walk through a custom load test. We're actually looking at code, and we're actually going to walk through all this stuff. Policies for the code that's up here, it's mine. It's all going to be Node.js. Redline does support PHP and Node.js. We're going to be using Node.js for our examples, but they do have a lot of PHP stuff, and I've written them in both PHP and Node.js. A couple things about Redline's Node.js. Their custom stuff. You upload a tar or a zip file. It will do an npm install. This is the greatest thing ever. As soon as I saw that, I was like, oh my god! I mean, it's obvious, but it just does it. So it does an npm install, so it installs the packages that you need. It expects that there's going to be a file called custom test.js in the root directory. The custom test.js file should export a class or a function or an object. It will create a new object. It'll pass in class, whatever class you name it as, Redline, and it'll pass in the Redline API or the Redline library. It'll pass in the test number, 1, 2, 3, 4, 5. A random number or random thing, and there's also a config that will pass in if you're using any config. This is all documented up on Redline. I won't bore you with all that. And then finally, it'll call the run test object of that class. So we're actually going to see what that looks like. One thing I like, before we get into the actual code, one thing I like about Redline and running the test is that if you do it correctly, you can actually run your load tests from your laptop before you ever move to Redline. Let me tell you, it's a lot of fun when you run your load test from your laptop. You're hitting the remote server, and then you can go to the people that wrote that and go, hey, my MacBook Air is taking down your system. I've done this. It is fun. Just because you write Erlang does not mean you know. That's a story for later. Okay, so we're gonna have so this is normal Node. We're not gonna learn Node here, but basically we set up the main script to be app.js. This is gonna be app.js where we're gonna run the load test locally, and that app.js is gonna include custom test, and that's where the load test will actually run. Make it easy, npm start, so I can run Node app.js, a normal Node convention. And then I also put together a little build test so I can do npm run build test in the command line. And then it'll run this command right here, which will essentially build a tar.gz file. And it's going to exclude the Node modules because Redline does an npm install. It excludes the Git directory, it excludes the logs directory, anything else that I don't want to include in the actual load test. Redline does have a limit on the size of the archives that you can upload because that's sensible, and text should not equal out to be megs of stuff. So this just strips it down to the essentials. This is app.js, really simple. Like I said, we're including custom tests, and we're also including a library called libredline. This is actually going to be a mock-up of the Redline API because we're going to use that. We want to be able to use it locally, and we want to be able to call the Redline API. We want to simulate that, and then when it uploads to Redline, we want the real Redline API to actually be used. And so in our case, locally, we're going to instantiate the new test, pass in the, actually I have the pointer over here, I don't get a chance to use lasers often. So it's going to pass in the Redline object that I'm passing in a hard-coded random number, well, hard-coded number of 55 here. I'm going to run the test, and then this is the callback that run test accepts, and lets me know that the test has been complete. I run this is going to run the load test locally from my machine. Oh yeah, I actually walked through all this stuff. I didn't even need to walk. I got these lasers. I did all this, and I did pointing up here. I freaking highlighted normally. All right. So this is Redline.js. So this is the Redline.js file. This is a mock-up of the class that Redline is going to be using. They have several different functions available in the object they're going to pass to you. Record page time records the page time. Again, this is all documented. Record URL page load. This is if you have different URLs that you're testing against, you can actually put in the URL that you're doing the test against. You can also, if you want, record the download size. Redline has a client that mimics being a browser, so it does a lot of the stuff automatically. So you could use that as well if you don't want to go through the process of doing all this custom stuff. I do a lot of API testing, so I tend to just use the custom stuff. Record error, which you can use to record error. It's also good as a logger, which I'll show you later. And you can record the progress if you want. It has a default progress bar, and you can do a more precise progress bar if you're tired, or if you want to see how much longer you have to wait. I also wrap the Redline API up in my own timer class, and all this does is what it's going to do is it allows me to have a simple start-stop time, and it puts everything. It handles all the timing. We're going to turn an active timer here. Active timer set up right here. And then finally, when we stop, we get end time, we do a diff. Here, I do all this animation, I don't even use it. Enter here for the record error. I'm recording the time diff. Again, I'll show you why. I just wanted to call that out. I record the page time. Here I record the start time. It expects a start time and expects the length of time it takes. I also in this case use the record URL page load, which takes the same arguments except for the URL as well. And I export both of those from Redline.js, Redline and timer. All right, so then we get custom test. This is where the actual test. This is what's going to be called by the Redline system when we actually throw it up to Redline. So for this, I'm including a bunch of typical libraries. You'll see I'm including timer specifically from Redline, the Redline timer. I'm not just including Redline and then what I want specifically the timer here, because Redline is going to be passed into me by Redline itself. So the Redline library I don't have to worry about getting here. A couple options that you generally want to consider when you're writing your custom tests. This is where we start getting to the meat of the actual the load test. So I usually like to set it up in the idea of minutes to run. How long do I want this load test to run? And so the idea here is that this load test is going to run for about 60 minutes. And we'll get to see exactly how we figure out 60 minutes a little bit down there. And then we also want to have sort of a ramp-up time. And so in this case, our ramp-up time is between 0 and 10 minutes. So you might have some starting up it's 30 seconds in, and some waiting until a whole 10 minutes later to start up. And this means that you're not just throwing 500 requests per second on your system all at once. It gives it some time to build up, to warm up cache and whatnot. And so that's usually a good idea. You want to add to your load test. I also want to make sure that I control the number of requests per second. So I have the idea of having a run every milliseconds variable right here. So it's by default going to run every second, run every 1,000 milliseconds. And I'll show you down there exactly how I do that. Well, basically what I'm going to do is I'm going to take the length of time it takes for the request to get back, subtract that from run every milliseconds, and then I'm going to set a timeout to say, hey, wait, let's say the request took 50 milliseconds. Wait 950 milliseconds before you call the next, before you run the next iteration of the test. Simple helper function for RAN because it's easy to do it that way. So this is the test. This is the start of the actual test. This is the class or the function I'm going to be returning from custom test that Redline is going to be using. So reloaded, it passes in the Redline client, the test number, the ready config, as I said before. This is the test. So this is sort of the mock test. So if you have your actual test, you can include this, and this will actually perform whatever load test or whatever test to the external system that you want. So if you're hitting an API, test would actually perform the hits to the API. And then finally, we're going to have the ramp-up call, and this is going to set up exactly how long this should wait to ramp up. And when we look down at the ramp-up, as I mentioned before, we're looking at the number of seconds that you want to sleep before we start up. And so here, we're going to call sleep and tell it to sleep for this many seconds before this instance starts up. And so Redline is going to, let's say we're doing 500 users, it will deploy 500 instances of this, and it'll say, hey, we're going to sleep this long, and that's what we're going to go ahead and do. Each one will sleep at a different rate.
Why the sleep? Why don't you start
So what I want to do is I want each individual client not to just, so your system is never really going to get 500 all at once. Maybe it will. But let's say you start the system at 500 requests per second, and then you start another load test at the same time. You want it to wait 20 minutes, and then after 20 minutes, it's going to start ramping up, right? And it's going to slowly hit a peak, and then it's going to come back down again. And so this means that you don't need to have something 500 users all on your site at once. It's now going to simulate people coming to the website and slowly, joining in and being a part of the website. More of a natural flow. You might see spikes. You can simulate spikes. You may not want to ramp up. You may want to ramp up. It all depends.
One of the points you make is also you want to see what starts to slow down first, right? So just ramp up.
Yeah. And so, like for example, if we're running 500 requests per second, so one of the tests that I did was I would start at 500 requests per second, and it would stay 500 requests per second. And then I started the second test, and this did the spike in traffic. Suddenly we got a lot of traffic in a short period of time, so the ramp-up time was, I started both the tests at the same time, but the ramp-up time for the second one was minimum 20 minutes, maximum 30 minutes. So over the course of 10 minutes, 20 minutes in, it would add in another 900 users. So again, it's dependent upon your application. You don't have to have a ramp-up time if you don't want to have it. It is good. It's important to realize, though, that ramp-up times can affect, if you're just looking at averages and things of that nature, that it's important to realize that it can affect just averages, which is why I generally recommend you don't just do averages. You look at percentiles. It's a better way of going about doing that. All right, so this is run test. This is the thing that's actually going to run the test. And so in our case, we're going to start off by setting a timer. And then what we're going to do here is we're going to take a look at the minutes to run. And what I'm going to do here is I simply say, all right, I'm going to assume that we want to do this many requests per second. So if I set it to 60 minutes, it's going to say, well, we want to do 3,600 requests over the course of minutes to run per second. So we want to set this so that we're running this many, in this case, based upon 1 second request per second. Yeah. So 1 request per second. So we start the timer here. We keep track of the difference in time here. And then now I'm going to call out to my actual load test. So this test, run a test. This is going to actually perform whatever URL we're going to perform the actual test. It's going to go out to the API. It's going to send the API this information. It's going to get the information back from the API, and it's going to call back to this callback function. And this function, all it cares about is once it gets this, to record the time. It wants to say, hey, this is what's happened. This is the end of the test. In this case, I'm recording the error if there's an error that's returned. And this again will be reported to you in RedLine. After this, we have we stop the timer. The timer returns a time diff, and I use that. If you can see right here. So the time series in this case returns a next function, and so this next callback, we call that when we want to run the next iteration of this function. And so over here, we simply take the run every millisecond, subtract the time diff. So if it's every 1,000 seconds, and this test just took 400 milliseconds to run, then we're going to wait 600 milliseconds before we call next again, approximately according to Node.js. That gives us approximately 1 request per second. And then once we're finished with all that, we finish and we return out from all that. Any questions so far? All right. So let's hack logging into the RedLine. So what I wanted to be able to do, so RedLine does provide some logging, we'll see that shortly. But what I wanted to do is have the ability to see the request per second in Node.js and be able to do percentiles. And you only can do that if you're using PHP to get percentiles and if you're paid, if I'm correct, right? Percentiles are only paid. So I wanted to hack RedLine to do this. And this was before we actually paid for the account. So what I'm using here is I'm actually recording the error of the time diff. So this is the milliseconds it took to actually run. So this will record 27 milliseconds. Now if you look on the RedLine results page, you'll see the error and you'll see the frequency. On the left-hand side, you're going to see what is the response time. On the right-hand side, you're going to see the counts. So you look at one of these, we had 19 requests take 27 milliseconds. And from there, you can get percentiles. Throw that into Excel, do a couple calculations, so you can get your percentiles. Again, Pro version does offer this, and the Pro version is not expensive. But the nice thing about the record error is that because it's doing all this logging for you, it's also useful if things are going wrong. You want to be able to see it right away. Oh my gosh, I'm hitting the wrong URL, so I would use this to validate that I'm hitting the right load balancer, anything that I wanted to do where I was logging out and I wanted to see it live. So that's where it's like, if it's running and like 5 minutes in, I'm looking at the log, I'm like, oh, I'm seeing these things I don't want to see. Something's wrong, let's just cancel this and start it again. And so Yeah. You definitely use record error functionality to go ahead and do all that logging that you want in real time. But as I said, it does offer the ability to save the response output from individual tests, and when you do that, you can download the individual tests, and it's going to give you the individual outputs. And then you can go into those outputs, and it'll actually report to you. You can see the response time, or you can see what's actually coming out of the what's being logged out. What?
Really?
What?
Really?
What?
Really?
Oh, damn! We get rid of that. Spend some time coming up with those things. So yeah, you can use error ring simulate real-time logging. The important thing here is that you're writing custom load tests. So there's a bunch of things you want to keep in mind when writing these custom load tests. So you need to understand the expected usage of the application or the system that you're putting under test. So, for example, you have X percentage of users using the app, the main portion of the app, while Y% of the users are chatting with each other on the app. And so what you have is two segments of the users. You might have 500 users, but they're not 500 users doing all the same thing, right? You have 400 users browsing through pictures and 100 users chatting with each other. And so you want to be able to account for that when you're actually doing a load test. In this case, what you're going to do is you're going to write two load tests. One using the app, one hitting the API endpoints, and the other one's going to be using the API endpoints to chat with one another. It's a lot of fun when you build a load test that's going to sit there and simulate chatting between two different users. You have users that are logging in, you have users that are creating accounts. You want to be able to test the fact that, like, let's say a lot of people are using the site, maybe a lot of people are chatting, and maybe this creates some sort of problem when people try to create accounts. You don't know. So these are things that you might want to consider, especially when you're load testing complete applications, APIs that back a mobile app. Back-end systems. How do back-end systems respond? These aren't necessarily things you're going to be load testing, but if you're sending a lot of requests to some third party and that third party suddenly can't keep up with whatever you're doing on the front end when you're load testing, it brings up a good point. If you're going to be doing any major load testing, and you're going to be hitting a third party, or you're going to be hitting AWS, or you're going to be doing anything like that, and you're doing a lot of load testing, best to inform the third party. Be like, hey, we're not doing anything malicious here. We just want to load test. Is there anything we need to concern ourselves with? Especially if you're going outside for the third party stuff, they may not appreciate that. Of course, it might also be a good idea to figure out if the third party can handle the expected traffic before you actually go to production. You wouldn't want to go to production and have suddenly the third party fall over. So it's up to you, working with the team, to determine what's important in terms of the usage. There's also, when you're writing the load test, keep in mind the input that the user is going to be providing. So you might, if you're searching if you're doing a search load test, so you're load testing a search application, you might consider, okay, well, we're going to test a query out. And then you might say, well, we're going to randomize some of the filters that people might be searching with. Even better, you might actually use weighted filters. You might say, what are people searching for now? Let's weight the results based on what people are searching for realistically. Maybe the application is going to be maybe the client is going to be caching some of those results, and you're not caching those results. So maybe that's something that you might want to consider. If you're expecting 500 real users to use the client, that doesn't necessarily mean you're doing 500 requests per second. So don't get caught up with the 500 users, 500 requests per second. You might want to also understand some of the client constraints. What's actually going to be what are the constraints that are put into the client itself when it's going to be hitting the system? So these are some things you want to keep in mind for users' input. in addition to that, you want to understand how the users are expected to use the system. If it's a new system, you have to really, you're going to have to go to product, work with QA, whoever's designing this thing to figure out how people are expected to use the system, where the flow through the app, understand how the users are going to use the app, and your script, your custom load test should actually try to mimic this as much as possible. Keeping in mind timings, how long it takes them to go from one screen to another. Your load test can hit it right after it's done, make the next request. A user might pause 3 or 4 seconds on a screen, 5 seconds, 6 seconds before going to the next spot. So you should try to mimic that as much as possible. You want to be careful about testing a single system alone. As I mentioned, you wanted this to be as I had the best results by testing a system in production or in a production-like environment. So if a system is alone, it has no dependencies, it doesn't have anything set up in terms of like logging or anything else. These are things that might create problems. Systems are going to have logging, they're going to have back-end services, and you'd be surprised about what can actually cause failure. In one of the recent projects we're working on, we had consistent problems with logs. You wouldn't think that logs would cause a system to go down. And this had nothing to do with the load test, but it's kind of awkward when the logs are the thing that are causing the problems for the system. And so you want to make sure that the system is set up in a way that, again, it's going to emulate that production stuff, the production environment. So if you're going to be testing a single system alone that doesn't have any of the stuff it's going to be having in production, we need to be very cautious about making any sort of recommendations based upon that. So the thing here is that a load test helps you learn before it's in production. You don't want to wait till you're actually in production before you start learning stuff. You also want to look and think about user interaction. So here at Mimi is a social network. So I've done load testing for chatting before, simulated chatting. So I would set up a single test. It would set up 2 users, and then both those users would chat with one another. An interesting story behind that, it's the Erlang story. So we outsourced the writing of this application, and I was tasked with load testing it, and one of the things it had was chatting. And so here I am building this whole chatting application and running it from my MacBook Air and testing things out. And okay, it's fun. You're seeing 2 people chat that you programmed to chat. And over time, what I ended up seeing was the longer the chats went on, the slower the chat would get. And it took a while. It didn't take a long time, but after 5, 6, 10, 15 messages back and forth, the response time started to go up. And the reason why that this happened was because just because you know Erlang doesn't mean you know databases, and they had to just add indexes, and that was a lot of fun to go ahead and add that there. But it's one of those things where if I had just built something that hit the API once and twice, or I ignored the chatting, we wouldn't have been able to catch that. And what ended up the real problem with that was, as the chats got longer, on the UI side, on the client side, on the mobile device, they weren't backgrounding that particular call to the API. So that call to the API was being done on the UI thread, which meant it would lock up the entire UI, and as it went out to get the messages, and this would be, at first it wasn't noticeable, and then it became, and as the messages got longer and longer, it became much more noticeable and more impactful to the app. Have the developers available. I've mentioned that before. Just things you want to make sure you do. Make sure you have the developers there. Better to have the developers there when you're load testing, not at a later date or not at another time. Make sure that they're sitting right next to you at the best possible time. Because if you have a problem, you have a question, you can turn to them and have them fix it. Find a problem, fix it, re-roll an app, rerun the test. I call this FFRR. Not really, I just made that up. Don't use it. As I mentioned before, start testing from your laptop. You'd be surprised about what MacBook Airs could bring down. Yeah, again, database indexes are a thing. And while you're actually running a load test, it's actually really interesting to actually run the single client from your laptop as well, just to get an idea of what a single client can provide. Also, if this is load testing an API that a mobile client is going to be in front of, someone should be testing that mobile client as well while the load test is going on, because response times are just a number. What you really have to ask yourself is, what does 50 milliseconds mean compared to 300 milliseconds when you're actually using the app? What impact does the load have on the actual use of the app? So you don't want to make that assumption. Just because this number is lower than another number or higher than another number doesn't necessarily mean it's going to make the app suddenly this huge mess that you can't use. It may be that in testing you discover that, okay, 100 milliseconds is not as bad as we thought. And again, when you're auto-scaling, when you're actually testing, how does the client respond? If you're auto-scaling out chat servers, for example, does the client disconnect and reconnect? How are these things going to impact the client that's connected to the system or that's using the system? Finally, with this, you want to also review how the client's using the API itself. How the developer expects how the client developer expects, or how the API developer expects the client to use the API. And you generally want to model your test after what the client is doing, but at the same time, you want to make sure you call things out that are different, because sometimes API developers and sometimes client developers don't always communicate like they should. They'll say, hey, here's an API, use it, and then mobile developers are like, hey, I'm going to use it however I want. And the expectation and how it's actually being used are completely different. So you want to call those out and then tell them to deal with it. Most importantly, you want to learn. Load tests are about learning things. Good load tests will teach you things you didn't know about your system. Great load tests will help you solve those problems before they become production problems. And in Russia, load tests you. Thank you. Any questions?
When you're running the local test off of your own hardware, how is it, do you know what it's doing for spinning up multiple instances?
The local test?
Yeah.
Oh no, it's just you run it locally. It's a normal.
One thread, or is it actually going?
It has nothing to do with RedLine.
Oh.
When you're running locally, that's why I have the app.js in there. So I run the app.js, which includes custom test.js, and it runs it. It simulates being RedLine, but it's still all running locally. And this is one of the things I really like about this is that I can run it locally without having to load up RedLine. So I can go ahead and make sure my custom script is doing exactly what I expect it to. Once I know it's working, I can go ahead and package it up and then push it up there really easily. It's a straight node application. You should be able to run this locally and not have to. And the PHP works the same exact way. You can do it the same exact way. The one problem there is make sure once you've run it and it's verified it's working, don't then make a change and then package it up, because then you'll be canceling it out. Never done that myself, but I heard it's not good. Any other questions?
Is this still only for AWS applications?
No, you can use this for, so it does deploy to AWS. You need to make sure that whatever system you'll be load testing will accept the connections from AWS, but there's no actual limitations on where it can test from. I just happen to most recently be using AWS, but yeah, you can load test whatever you want with it.
Have you done or considered putting load testing as part of Twitch integration schedule at all? Or is that a little too heavy?
So you could do that, but you wouldn't want to do it against the production system. So you'd have to have some system that automatically rolled all this stuff out, that set everything up, and then automatically deployed all this. So RedLine does have Jenkins integration. You can set that up and have a Jenkins job and press it. It's really easy to set that up. The one issue I have with that is it uses the description and it puts it, it's a little funky with that, But let me put it this way. You install the Jenkins plugin, which is incredibly easy, and you're like using it. It just works. My biggest compliment I give to any product these days is it works. It does exactly what it promises to do. When it does that, like, oh my God, it does exactly what it promises to do. So yeah, but it does have that capability, so you could do all that, and you could have that part of the continuous integration process, assuming you were able to deploy this. If you're in development, you could easily do that, I guess, if you wanted to. But you'd have to make a lot of stuff have that happen. And then you could, of course, I think with the Jenkins plugin, you can set it so that if the average response time is too high or something, it'll fail. So you could have that built in and stuff like that. There's that.
So you use that entire smoke test.
Yeah. It's pretty sweet that way. Any other questions? All right, well, I'd like to thank you all for coming out. Once again, we usually head over to Triumph afterwards. We're going to have another meetup again next month on QA automation. Probably be a much more interesting speaker than me. Apologies, we had the speaker that was supposed to be speaking this month canceled last week, so I had to prepare this talk fairly quickly. But thank you all for coming. So, and have a good night. Drive safely. I gotta stop the stream.